Okay, so for number 10, do we have either a sample size greater than 30 or a normal population? We have a normal population, so yes. The answer is yes. With that first requirement met, that means we can now use the Z or the T distribution. Then we look, is sigma known? Do we know what sigma is?
Yes.
Yes, sigma is 27. So what do we use? Z. Okay, how do we find critical values for the Z distribution? We're going to use the inverse norm. Over here we have 98% in the middle, 0.98, and then 1% in each tail. And so we add these two areas together and we have inverse norm of 0.98 plus 0.01 is 0.99. And that is, I think, one of the ones given on your formula sheet. But if you don't have it given, you can just put in inverse norm of 0.99. And that is 2.33. So Z-scores are always rounded to 2 decimals. T-scores are rounded to 3 decimals, which is, when you look at your table, you can see, hey, there's 3 decimals every time. Therefore, you're going to round it the same way. Okay, number 11. First question is, do we have a large enough sample size or a normal population? Yeah, our sample size is 45. So yes, we're okay with that requirement. Again, either Z or T. Now we're going to look further. Sigma is known. So what do we find? We're going to look for Z-score or Z distribution. Okay, this time it's 91%. That is not one of the ones that's listed, so we definitely want to draw our little curve. Say, okay, we have 91% in the middle, which is 0.91. That leaves us with 9% in both tails, or 4.5% in each. Now we're going to find this critical value by adding the middle and left tail together. So it's inverse norm of what area? Inverse norm of 0.955. And that is 1.69, which is rounded to 1.70, rounded to 2 decimals. So A is our answer over here. Okay, number 12. Do we have a large enough sample size or a normal population? Normal population. We just need one. Sometimes we have both of those conditions met. Sigma is unknown. So this time we have the T distribution. Okay. We are looking for 99% confidence. We already labeled our table 99 confidence. That was our first column. And then this time we need what else? Yeah, so we need to find the degrees of freedom, which is n-1 or 16. So go down to 16 degrees of freedom. And what is our critical value? 2.921. Over here, C. Okay, number 13. Do we have a normal population or a sample size big enough? Normal population. Do we know sigma? No. So what do we use? Okay, this time it's 90%. So 90% was the second to last column. Our sample size is 10, which means our degrees of freedom are 9. So last column, no, second to last. Going down to 9 degrees of freedom is 1.833. And then the last question, we have do we have a sample size large enough or a normal population? No. So we don't even have to find the t or z scores because our answer is going to be A. Neither the normal nor the t distribution applies. It just could say that it's not normally distributed, but very skewed just means, if it's just a little bit skewed, we may be okay, but because it's very skewed, our answers are going to be very different. Okay, so we're now actually going to calculate a t interval. So we're going to do example 2 right here on the bottom. So let's write down the formula for our t distribution for our margin of error. So this is equal to t alpha half times the standard deviation of the sample divided by the square root of n. And then we're going to take our sample mean and we're going to subtract the margin of error, and we're also going to add it. So just like before, we will do one example manually and then the next example, and then we're going to calculate it. Also do the calculator shortcut, but the idea is from now on, I want you guys to simply determine, hey, I can use, this is the t distribution, right? And therefore I'm going to use the t interval because I'm trying to estimate the mean. So you have to look at the verbiage, figure out which one is the correct distribution, which one is the correct parameter, and then use the correct shortcut. So flash ease of reading scores for 12 different pages randomly selected from J.K. Rowling's Harry Potter and the Sorcerer's Stone found a sample mean of 80.75 and a standard deviation of 4.68. Find the 95% interval estimate of mu, the mean flash ease of reading score. The 12 pages distribution appears to be bell-shaped. So the reason why they put that in there, because remember our requirement is either a sample size greater than 30 or a normal population. So because it states over here that these are bell-shaped, we're going to assume that we have a normal population over here. Okay, so let's calculate. So we have t alpha half, and we have n equals 12. We have an x bar of 80.75, that's our sample mean, and a sample standard deviation of 4.68. So you can see it doesn't specifically say, hey, this is your sample standard deviation, but it says here's our sample and that's the mean and the standard deviation. So you can assume, well, this standard deviation describes your sample. Okay, so, and we have a 95% confidence. What is our degrees of freedom? 11. Okay, so go to 95%. Go down to 11 and look at your critical value. So your t alpha half is 2.201. So margin of error is equal to 2.201 times the sample standard deviation that was given, 4.68, divided by the square root of your sample size. And over here, 2.201 times 4.68 divided by square root of 12 gives us a margin of error of about 2.97. Now we're going to take the x bar, and we're going to subtract the margin of error and then take the x bar and add the margin of error. So 80.75 minus 2.97 and 80.75, maybe we should just carry one extra decimal point. Let's do 4. Because we want to make sure we actually round it to, we're going to round it the same way as our mean was rounded, but you want to carry one extra decimal and then round it afterwards. So 80.75 minus, in fact I can even highlight it and paste it right in here, and then round it to 2 decimals, that's 77.78. and then taking the mean and adding the margin of error to it and rounding to 2 decimals, that's 83.72. So our confidence interval goes from 77.78 to 83.72. And then it has a little explanation below. It says the output of Flesch reading ease formula is a number from 0 to 100 with a higher score indicating easier reading. The average document is between 6 and 70, so when you compare the confidence interval, you could say, hey, this is easier to read than the average document, right? So now let's compare. So this was the short way, doing it manually, calculating the critical value, multiplying it all together, finding the margin of error, and then subtracting and adding the margin of error. But we are going to look at the shortcut, which is, we are using a t-distribution. We are estimating the mean. We use the t-interval for that. And so we're going to find that under stat, test, error down to t-interval, which is option 8. Do we have data or summary stats? Okay, so we're going to highlight stats. X bar is 80.75. Our sample standard deviation is 4.68. Our sample size was 12. Our confidence level was 95, so 0.95, and then we hit calculate. Notice again that over here it's asking for an S, not for a sigma. So if your question has a sigma in it, another way to indicate, hey, I'm maybe in the wrong distribution. Or if it has a sigma instead of an S, hey, maybe you did Z interval instead of T interval. So these are ways to catch kind of mistakes you're making. Okay, so you only hit enter once. On the very top is your confidence interval. This starts from 77.78 to 83.72. It is rounded to the same number of decimals than was present in your sample data over here. Okay, any questions?